Good afternoon, everyone, and welcome to 8.4 Solving Equations. Let's begin. The first question is 1 over 3 times 2x minus 1 equals 1/2 3x plus 1. So the questions are a little bit more complicated now than they were at the beginning, but the process remains the same. Now, what makes this question different than some of the other stuff we've been doing is that here we have an x located on both sides. Okay, so one of the first decisions we're going to have to make here is decide which side we want to isolate all of our variables. We'll get to that in a minute. The first step I want to take in this question is I want to get rid of the fractions. So rather than distributing these fractions here and here, I'd rather get rid of the fractions and deal with whole numbers. So I look at the multiples, or the denominators, there's 3 and 2. So a multiple of both would be 6. So the first thing I'm going to do is multiply both sides by 6. Okay? What this will accomplish, 6 and 3 cancel out, leaves us with a 2, and 2 times 1 is, of course, 2. 2x minus 1. Here, 6 divided by 2 is 3. 3 times 1 is 3. 3x plus 1. Now, the question looks a little bit simpler, right? Now we've got a variable on both sides with some brackets. So the first thing we're going to have to do here is we're going to need to eliminate those brackets, and we're going to do so by distributing to both sides. Okay, so 2 times 2x is 4x. 2 times negative 1 is negative 2. Equals 3 times 3x, which is 9x, and 3 times 1, which is 3. At this point, we have to get all of our variables onto the same side. Now, whether you want to gather your variables all on the left side or all on the right side is up to you. I'm going to gather them. I traditionally like to gather them on the left side, but again, there's no wrong answer here. So I have to move this 9x. So this is positive 9x. The opposite of that would be negative 9x. So the opposite of positive 9 is negative 9. I have to subtract 9x from both sides. 9x minus 9x is canceled. 4 minus 9 is negative 5x minus 2 equals 3. Okay. Well, now the question looks more like something we did in 8.2, so a little bit easier to deal with. Negative 5x minus 2 equals 3. The opposite of negative 2 is positive 2. We add that to both sides. Those cancel. Negative 5x equals 5. Now this is negative 5x. We have to get rid of the negative 5. The opposite of timesing by negative 5 is to divide by negative 5 to both sides, leaving us with x equals negative 1. So to recap, the first step was to eliminate the fractions. We did that by finding a multiple of 3 and 2. Then we distributed on both sides to get rid of our brackets. Then we gathered all of the x's on one side. I chose the left side for this particular question. Then we moved the 2 to isolate the variable, divided by negative 5, and we're done. Let's try another. So take a minute, write this down. 6x minus 3 over 5 equals 4x minus 1 over 3. Once again, before we do anything else, we need to eliminate those fractions. Anytime we can eliminate the fractions, that's what we want to do. So we look at the denominators, 5 and 3. The multiple of 5 and 3 is 15. 15 and 15. So multiplying both sides by 15 will eliminate our fractions. 15 divided by 5 is 3. So the 5 is gone. The 15 becomes a 3. 15 divided by 3 is 5. So the 3 is gone. The 15 becomes a 5. And away we go. Now, this point is an important next step. Too often students just multiply the 3 by the 6x, and then they write down 18x minus 3. But that's actually incorrect. That 3 has to be distributed to both the 6 and the negative 3. So I like to write it down like this in brackets so I can distribute properly. Just like over here, the 5 has to go to the 4x and the negative 1. So I write it down in brackets. This allows me to now distribute to both terms on both sides to ensure I'm doing it correctly. 3 times 6x is 18x minus 9 equals 5 times 4x is 20x minus 5. At this point, we want to get all of the variables onto one side. And again, you want to gather them on the left side or the right side, it doesn't matter. Normally, I like to put them on the left side just because that's what we're used to. So the opposite of positive 20x is, of course, negative 20x. So I have to do that to both sides. Make sure when you're putting the minus 20x here, you put it underneath the 18x because those are the like terms that you're going to be combining. So 20 and 20 cancels. 18x minus 20x is negative 2x minus 9 equals 5. Now we're back to something you would have dealt with in 8.2. We have to move the negative 9. The opposite of negative 9 is positive 9. We do that to both sides. Those cancel. Negative 2x equals 14. Last step, eliminate the negative 2 by dividing both sides by negative 2. X equals negative 7. So once again, start by looking to eliminate the fractions, then distribute the 3 and the 5 to both terms, then get all the x's together on one side, and then isolate that variable. All right, this is one for you to try on your own. So please write this down and try it on your own right now. And the answer, I will start to work out the answer now as well. All right, the answer we are looking for is x equals -5. Let's go through the steps. The first step is to multiply both sides by 4, because 4 is a multiple of 4 and 2. That will eliminate the fractions. So 4 and 4 cancel out, leaving us with 3x plus 1 on the left side. Over here, 4 divided by 2 is 2. So we have a 2 left over. We're going to distribute this 2 to both the 3 and the 2x. 2 times 3 is 6. 2 times 2x is 4x. At this point, we're going to gather all of the x's on one side. The opposite of positive 4x is negative 4x. I minus 4x from both sides. Now I have negative x plus 1 equals 6. The opposite of positive 1 is negative 1. I minus 1 from both sides. I'm left with negative 1x equals 5. I have to get rid of the negative 1, so the x can be by itself. So I divide both sides by negative 1, leaving me with x equals -5. Hopefully that was successful. Let's try one more here. Here is a problem-solving question, and this one occasionally can be tricky for students, so we'll work through it together. In a jar of coins, there are 30 fewer quarters than dimes. The value of the dimes equals the value of the quarters. How many dimes are in the jar? So the first thing we have to do in any problem-solving question is we have to establish the variable. We have to establish what we are looking for. And of course, we are looking for dimes. So we'll make dimes D equals dimes. And what we know, we have to set up our equation. So we know that there are two things we have to deal with here. We have to deal with dimes, but we also have to deal with quarters. And we want to try to avoid having two different variables, so otherwise we can't solve it. So we need the quarters to be related to the dimes somehow. Well, the question tells us there are 30 fewer quarters than dimes. So if there was 50 dimes, 30 fewer than that would be 20. So if the number of dimes is D, the number of quarters is going to be D minus 30, because there are 30 fewer quarters than dimes. And that's really the most important, well, that's one of the big important steps of this question. The next you're going to see in a moment here. We have to set up our equation. Now it says that the value of the dimes equals the value of the quarters. So we know there's an equal sign in the middle. The value of the dimes, D, equals the value of the quarters, D minus 30. The problem is that right now there's still one thing missing from our equation. And what that is what the value of the coins actually are. So the dime is worth 10 cents, right? The dime is worth 0.1 of a dollar. So for the dime, I need to add 0.1 D, and the value of a quarter is 25 cents, 0.25. So here, I'm going to put 0.25 for the value of the quarter. Now this becomes a question we can actually solve, because now we've given the 0.1 as the value of the dime, and the 0.25 is the value of the quarter. Now we can figure out how many dimes are in the jar. Let's fix that. Okay, so the first thing we have to do to solve this question is we have to distribute to get rid of the brackets. So on the left side, we still have 0.1. Let's do that correct color. 0.1 D. equals 0.25 D minus 30 times 0.25, which is 7.5. So now I have 0.1 D equals 0.25 D minus 7.5. So here I have variables on both sides of the equation. I have to get them together. So I'm going to move the 0.25 D over to the other side. That'll be negative 0.15 D equals negative 7.5. Now I have to divide to get the D by itself. If I divide both sides by negative 0.15, I'm left with D equals 50. So if there are 30 fewer quarters than dimes and the value is equal, that means that there is 50 dimes in that jar and there's 20 quarters. Okay? So the most important steps of this question was making the dimes D and the 30 fewer quarters than dimes, D minus 30, and then remembering that the value of a dime is 0.1 and the value of a quarter is 0.25. We have one more question left. I believe. Oh, two left. Here's one for you to try on your own. So you can pause the video now and please give this a try. The question says, in a jar of coins, there are 20 more nickels than quarters. The value of the nickels equals the value of the quarters. How many quarters are in the jars? So please pause now and give it a try. Oops. All right, this question says there are 20 more nickels than quarters. And the question wants to know how many quarters are in the jar. So we make quarters, I made it X. And there are 20 more nickels than quarters. So then I made nickels X plus 20. Now the question tells us that the value of the nickels equals the value of the quarters. So I had X on one side and X plus 20 on the other side. And then I have to add the value of the coins. A quarter is 0.25 and a nickel is 0.05. Next, to solve, I have to distribute on the right side to get rid of the brackets. So I have 0.25x equals 0.05x plus 1. I minus 0.05 from both sides. Then I divided by 0.2, leaving me with x equals 5. We have 1 to go. It says Alan has $35.50 and is saving $4.25 a week. Ava has $24.25 and is saving $5.50 a week. And how many weeks will they have the same amount of money? So, the question wants to know about weeks. That's what it wants us to find. So we're going to say x equals weeks. The question also states something very important. It says, when are Alan and Eva going to have the same amount of money? The same being equal, right? So we're going to put Alan on one side and Eva on the other side. Well, Alan is saving 4.25 per week, plus he also had $35.50. Eva is saving $5.50 a week, plus $24.25. If we can solve for x, we will know in how many weeks will they have the same amount of money. Because while Alan started with more money with $35.50, Eva is saving more per week, so eventually she'll catch him. So to solve this, I need to get the x's together. So I'm going to gather the x's on the left side. This is positive 5.5. The opposite would be negative. That'll cancel out. 4.25 minus 5.5 is negative 1.25. X plus 35.50 equals 24.25. Next, we're going to start to isolate the variable by moving the 35.50 to the other side. $4.25 minus 35.5 is negative 11.25. Final step is to divide both sides by negative 1.25, excuse me. So cancel. Leaving us with x equals 9. So in 9 weeks, Alan and Eva will have the same amount of money. That brings us to the end of 8.4. Here is your assignment. Page 327, 6 to 13, 15, 26, 27, and 30. Thank you and have a good day.